Hey, this is Mr. Mitchell with another video about these subatomic particles and what they have to do with the periodic table. So we mentioned that protons, neutrons, and electrons are building blocks of atoms, which are building blocks of elements, which are building blocks of the daily compounds that we see. So the size or the mass of a proton, neutron, electron are very, very small. But there are two of them that are about the same mass, and that is the proton and the neutron. And scientists think they've kind of narrowed it down to a proton is about point many, many zeros, 167 grams. Same thing with a neutron. And that an electron is even smaller, that if you take the incredibly small proton or neutron and divide it by 1,800, you'd get the approximate mass of an electron. So those are some really, really hard numbers to work with. So somebody was pretty smart. Somebody was pretty smart a while back and decided to just create a whole new unit that how much a proton and neutron weigh is one AMU. So these mass units make it much easier to talk about the mass of a proton or a neutron, and an electron is generally known to have no mass units. So you don't even regard the electron when talking about weight of any of these subatomic particles. So that's going to kind of lead you into some stuff on the periodic table. So each of the periodic table has dozens of these little rectangles, I guess you'd call them squares. Dozens of these little squares that represent a single element on it. Here's the one for oxygen. The element symbol is O, and the name is oxygen. Now we have a number that's generally above or in the top right, and we have a number that's generally at the very bottom. The one at the top is going to be called the atomic number. The atomic number is the number of protons that are in one atom of oxygen. So there are 8 protons in one atom of oxygen, and that does not change for any atom of oxygen. Every single atom of oxygen has 8 protons in it. And you can tell it because the atomic number is 8. Now, that's also the number of electrons in a common oxygen atom. You can have fewer or more electrons, but you cannot have fewer or more protons from the number that is the atomic number. Now, the atomic mass is the weight of that one atom of the element. So you had in one atom 8 protons. The weight of it is 15.999. Now, if you have 8 protons and 8 neutrons, that adds up to 16. So you may wonder, why is it 15.999? And the reality is that just like you can have a variation of number of electrons, you can also have a variation of a number of neutrons in an atom. So this atom of oxygen has 8 protons, 8 electrons in most cases, and in almost all cases 8 neutrons. But this number is an average to represent that sometimes you don't always have 8 neutrons. There's every once in a while you'll have 7 neutrons. So the mass is not a whole number because elements may have a different number of neutrons. So that mass is an average. So you can take a look at each individual square on a periodic table and find out the number of protons, neutrons, and electrons. In this case, it's 8 protons, 8 electrons in most cases. You can just say it's 8 in this case. And the mass minus that number, the atomic number, is going to be the number of neutrons. Mass minus atomic number is going to be neutrons. In this case, It is almost 16 minus 8, which means 8 when you round it up. So I want you to be able to look at any given square on the periodic table and be able to tell the number of protons, the number of neutrons, and the likely number of electrons in each of them. So, how do you find the number of protons? Correct, it is the atomic number. How do you find the number of neutrons? Subtract the mass, or the atomic number, from the atomic mass. In this case, it rounds to 8. How do you find the number of electrons? Yes, you can say that it is the same as the atomic number, though in reality you do have some slight variations. So, can an element, like oxygen, have a different number of protons? No. Whatever the number says on top of the element is going to be the number of protons it has. If it has a different number, it's not oxygen. It is something else. The protons determine what it is on the periodic table, and it will change if you have a different number of protons. Can it have a different number of neutrons? Yes, that's why the number is not an even number. When you have an element that has a different number of neutrons than its protons, you have an isotope. So there are just enough isotopes of oxygen to where that number is not exactly at 16. Can you have a different number of electrons? Yes, you can. We mentioned that before, but we did not mention that when you have a different number of electrons, it's called an ion. And anytime you have an ion, you have a charge, because electrons have a negative charge, and if you have more electrons, then the whole thing is negative. But if you have fewer electrons, then the whole thing is positive. So we're getting the building blocks of looking at the periodic table as a whole. And now we know a little bit about how we find the protons, neutrons, and electrons. I'm looking forward to learning more on the periodic table.